Hey, hello there. I hope everything just works fine. I hope. Oh, yeah. Maybe it's too. Let's try it again. Let's try it again. Yeah. It seems that it works just fine, but let's try it again. Yeah. Yeah, it makes sense. It's working. Yeah, it definitely works. Yep. Haven't been streaming for a while, but yeah. I hope yeah. I hope this stream will be a bit interesting in the other ones, because here I will be much more coding and yeah. So yeah, I will be coding. I'll be working on a project called Tetroflow, which is basically a oops. Do you see that? See, oh, which is basically a replacement for Redis. But I think it's a better one, obviously, and it's truly open source, because Redis does I believe Redis doesn't have a bunch of. Wait a second. Oh, I don't know whether the title was updated or not, but yeah, it should have been actually. It should have been actually. It should have been, but wait a second. I'll just have to check my channel. Yeah, yeah, it kind of works. It kind of works. So yeah, um, I unfortunately deleted a pretty huge part of the code, because yeah, um, because well, I was trying to do the replication. So yeah, first I'll tell something about the Tetraflow. Yeah, this is kind of in-memory database, which is a synchronous, not asynchronous, but synchronous database. So basically, there's just one thread, main thread, which is running and executing transactions. And it was written by me, obviously, in modern C++, C++20, but I think I will even switch to C++23, because it has some more. It has just even more new functions, objects, data types, etc. The standard library is even better there. So yeah, and I just removed a pretty huge part of the uh, whole creation mechanism. Yeah, but I created a new branch. Yep. Oh, it just, yeah, as you can see there, there's a bunch of code here. I really actually have a lot of code here with a lot of queues, and it was basically a half broadcasting, half gossip replication algorithm here. But yeah, but it was using JSON, and this is the thing I dislike the most. for some reason. It really kind of feels unprofessional, right? So yeah, using JSON, I mean, it uses JSON to communicate with the client, obviously, which is much more convenient and much easier. But I mean, using JSON to yeah, communicate between the nodes. First of all, JSON has a lot of yeah, JSON has a bunch of limitations. First of all, it's yeah, it's I think JSON. First of all, JSON cannot you cannot send in well integers longer than 32 bits. Why? Because I don't know, but you can send pretty large strings. So what I did first is it again. Yeah. Oh no, it's not the node ID, but I first wanted to take a look. Actually, I tried to do what basic Cassandra did, but yeah. So I was trying to take a look at the JSON message leaf. There weren't even used here. I didn't use parse message, empty callback. Yeah. And then execute the command to add it to the queue and execute the command, which was the best option, I think, which could lead to some inconsistency. Yeah. So where the hell was it? I think yeah, it's here. It's message duplicate. So see, like the timestamp here, std to string get timestamp. So yeah, it basically I had to cast all the longer and the I think the it's 2024 now, and the limit of the 32-bit integers will be reached by 2026 6 or something, but yeah, I'm not sure about that. And yeah, so we'll see. But for some reason I got an error. I got a bunch of errors that this the data was outside uh of the normal 32-bit range for some reason. But yeah, again, we'll see. So yeah, so again I had to cast it to string and send it as a JSON string just normally, and then cast it back, and it works just fine. But yeah, for some reason I really disliked the whole stuff. I thought the implementation kind of felt unprofessional from the beginning, because all the rest of the commands here, well, first of all, I just yeah, I just created a new branch so I can revert to all the changes in at any moment. Yeah, but let's design something new, some new replication system, for example, or something like that. Let's see what we can do. But actually, I want to take a look at SkillaDB. Just yeah, wait a second. Skilla, I like how that works, and display capture is the wrong. Is the Yes, so yeah, so yeah, I want to take a look at the SkillaDB and how they implement the whole stuff. So maybe take a look at ChatGPT. What would it suggest me? But you see, there are a lot of companies which adapted this Kiva, and it's cool. But yeah, I actually don't see the Discord here. That's the that was actually why I found out about the Skila DB. It's because Discord switched to the Skila because of the yeah, high throughput, etc. Mm-hmm. Yeah, yeah, I know. It's availability, etc. Website's kind of good. It looks looks very good. So let's see at the Skila DB architecture that interesting me the most. Um, uh, maybe. Yeah, obviously, Medium is talking about him because yeah, it's we saw it's using SkillaDB. Yeah, so custom caching system, blah blah blah. Various workload steps, prioritize suites over rights for latent sensitive scenarios and background with actions don't interfere with the primary application traffic. Yeah, maybe. Same tunable consistency levels, accelerated field consistency per read. Right operation for replication. This is highly efficient consensus protocol based on Raft and compilable access algorithm. Ah, that's what I was looking for. Access algorithm. Proposal acceptor. Computer science. Well, I have I have algorithms and data structures, advanced course at the university, visiting it, right? And that's in this semester. But yeah, we didn't learn about that. We're kind of more making the AVL trees, writing AVL trees ourselves from scratch, etc. But it's not that bad also. Consensus or fallible processes. Consensus is the process of agreeing one result among a group of participants. Yeah, I know what consensus is, but it's something blockchainy. For me, it's something blockchainy. So it's a thread of the blockchain where there is actually a consensus, also the consensus already in blockchain. State machine or replication for into fault tolerant distributed implementation ad hoc techniques. Mm-hmm. Praxis. And the includes spectrum channels between B2 uh, usually and types of deterministic fault tolerant consensus protocol can guarantee process is an asynchronous network. Well, I wanted actually to keep everything synchronous, so no locks, no deadlocks, no concurrency, no nothing. This is why, for example, I have just one runner here. Yeah. So transaction manager handles the queue and commits the transaction, and this is where how transactions executed. So there's basically this for while true loop, which does the whole stuff. So yeah, assumptions. and then make the aperture longer to deliver. Messages may be stored and duplicated. Make consensus F to M. Some processors despite simultaneous failure. In other words, number of non-faulty processors must be strictly greater than the number of faulty processors. Protocol may be deployed. Yeah, that doesn't tell me that much about it. It's more just kind of abstract stuff. User acceptor. Yeah. Information judge accepted most information. Information. Yeah, it still doesn't tell me that much. Okay, oh, I don't know the game. Ref replication information management. Ref replication. Oh, so it kind of splits the data, does it? Application Java, yeah, or Java, obviously. Yeah. So alternative to Paroxys family, Texas family, it was meant to be more understandable, hopefully. Logic, but formally proven safe and yeah, for okay. I mean, it's not much that it's formally proven safely, but safe, but additional features. Well, that oh, someone's joined. Hello there. So yeah, actually, the music in the background. Oh, it's too loud. Yeah. So yeah, that's kind of what we might try to implement here, but reliable, redundant, fault tolerant. Yeah. Um. Consensus, a leader election. Oh, so there is a leader election. That's exactly what I kind of wanted to avoid because yeah, again, I like how it's implemented in Cassandra where there's no basically no main node or yeah, but it kind of seems like all the algorithms are relying on it. So yeah. Consensus via an elected leader. A server is a ref. In a ref cluster is leader or follower. Can be candidate in the precise case of election leader unavailable. Oh, so it handles the leader's unavailability, the possible unavailability, right? Yeah. Yeah, so yeah, there's the music. So yeah, basically that's the biggest difference to Apache Cassandra. So the Cassandra doesn't have a leader at all. And here it will the leader selected, but it's not it can be and it can be changed at any time. So informs the followers of the existing heartbeat message, alright? Yeah, heartbeat. Each follower is having a timeout. Yeah, right. Which is expects a heartbeat from the leader. The timeout set on receiving. If no heartbeat received, the follower changes status to candidate and starts a leader election. Wow. I won't get political here, but yeah. elections now. Huh. That's a pretty hype topic right now. Consensus leader. The cluster has one of which is fully responsible for local replication, but the other source of the cluster real. Yeah, that's pretty interesting. How is it done in terms of the period of the serve for which a new leader needs to be elected? Each term starts with a leader election. If the election is, yeah, but how is it done? But how? How does a node know? Well, let's imagine there are some nodes, right? And there is some, and the leader nodes just yeah, just goes offline. So basically, every other node tells, well, I'm a candidate now. So how do they choose now the leader? Server will be first come first served basis. Of candidate receives a message from another server with a term member term member larger than the candidate's current term. Candidate's election is defeated and the candidate changes to a follower and recognizes the leader as legitimate. Wow, that can be really, it kind of gets a bit political here, but yeah, guys, we're talking about computer science and about the replication stuff, not about politics or something. If a candidate receives majority of votes, it becomes a new leader. So basically, the first node which tells the main leader is offline. Now I want to be a leader, or if I get it right. So yeah. But how is it? Is it done? But how does the would the connection look like? It's interesting me most because in Skila, let's see, fault tolerance. Yeah, ring architecture. I don't actually understand how the ring architecture. Oh, someone's joined. Hello there. Yeah, so I don't really actually understand how this ring architecture works, because in Cassandra, again, I didn't just try, I implemented the Cassandra at the Cassandra gossip algorithm. First of all, in Tetroflow here and in the application. Yeah, hello. Yeah, hello there. So, yeah. What I'll again, I will repeat what I'm talking about here. So this is a small project I'm working on here, which is basically a fast replacement for Redis, because as we know, Redis got a bit it always was kind of semi open source, right? The open source Redis, the real open source Redis didn't support many features the paid Redis did, etc. So, and also the Redis does not actually there is no proper replication. It can get a point of single point of failure in most of systems. Again, especially if it's an open source version. Yeah, so I think they made their license much stricter some time ago, so I decided to take a look at the more C++. I wanted to first of all I wanted to yeah, write something in more C++, maybe apply all the knowledge I acquired at the university with all the modern data structures, yeah, transactions, how exactly they work, how databases are built, and much more. So yeah, that's why I just created this project. The link, it is in the description if you're kind of interested. And well, I tried to implement a replication system on this project, and I kind of succeeded, but it used JSON to basically exchange the commands, like write ahead log, but yeah, I kind of now disliked it and disliked the whole architecture of the meshed networks and how it works. So yeah, now I'm looking forward to re-implement the algorithm, the replication, and synchronization algorithm to, yeah. And I'm just taking a look at ScalaDB, which is as I understand it, like one of the best solutions for such distributed databases in the market, which is actually better than the faster and more efficient than Cassandra. So yeah, I'm trying now to basically reverse to some degree to understand how it works, and yeah, and re-implement such thing. But yeah, I hope I succeed. Partitioner, hash values, production key. Yeah. So in my case, it's much easier because here the ScalaDB is a NoSQL storage with a, I think it's called document storages or something, which aren't. Okay, I'll change the music. Oh yeah, the damn advertisement. Sorry. Yeah, sorry. Yeah, and I'm trying to implement it now. So yeah, in my in the Tetroflow is a again it's an in-memory storage with a key, and keys being only signed integers of 32-bit length. I'll maybe extend it later, but yeah, cluster information, simple snitch. I'm college now learning C++ is live stream, but only basic. Want to learn which level software. Learn. Yeah. C++ is pretty. Yes, C++ is. Many people say that the C++ is deprecated now, and that the C++ is that it will be replaced by Rust, and no fucking way, it will never ever be replaced by Rust. Yeah, again, so I worked for a time for a time ago with some embedded C++. With it wasn't actually full C++. It was more of a embedded C, right? With some small C++ features. Well, actually, I couldn't use anything, like no hash maps, no modern data types, no nothing. The only thing I could use from C++ were the classes and objects and some small stuff, but that's it. Again, and now I switched to more C++, and it's very, and it's, if you know, for example, Java or something, it's really it can get it's much easier. So yeah, C++ is still a thing, and if you say you want to learn it, then just go ahead and do it. Yeah. So yeah, again, why am I doing this project on the first thing is I wanna also learn something about databases and apply the knowledge I got at the university. Yeah. So stored in and replicated across nodes. Yeah, but how is the connection? What's the connection? How are the network connection built? What did it look like? The whole network connections. And yeah, by the way, if you know just the basics, yeah, if you just know the basics, it's more than enough, actually. Yeah. Also, don't consider myself a C++ pro, but some basic data. I mean, I'm just I'm making my second year at the university, and I just I think I know enough for more or less comfortable work in software development. So if you went to the college, it shouldn't be a problem. At least sometime at the university where I study, after a year you can pretty much be, after a year you get a certified Java developer after just a year. So yeah, again, I don't think it's a problem. So only required when adding and removing nodes, second is on building kits. streaming data from all available nodes. Again, I don't understand how they connect. I mean, it's obviously a proprietary, it's a half proprietary software. I'll look at the source code. Yeah, maybe try again. There's source. It is sources there, but I'm not sure. Raft. Oh, this is the raft. Maybe take a look at that. Consent. Oh, it's more of a consent. Yeah, it's more of a consensus than replication. Streaming pair Redis. What the fuck? Okay. Message. Mistake of messages are passed. HH. What does this HH mean? Query partition range. Oh yes. So this is what partitions. I think in this case, they're in the database has like pages. At least we learned that there are pages, but in this case, I think they're just telling, well, they're calling a page actually partition because it's how they split the data. Because they, as I know, the Scala DBs there are. Handling the data on a physical CPU level, they assign some data range, data package to the physical CPUs to balance out the load. In my case, it's not necessary. Yeah, but there's some serious modern C++, as I see. There's some serious shit going on here. Make sync for repair get roll difference with RPC stream. Oh, they're using RPCs. Yeah, they're okay. That makes it more procedural. So yeah, that makes it easier. Now I kind of get it more. Okay. Is it possible? Making a basic RPC. Yeah, so they are connecting their service with an RPC, which makes it yeah, that kind of makes sense. Because yeah, I can show you the just a sec. I can show you the old source code. Yeah, there's some standard license without anything. So there's the gossip algorithm to there's a gossip algorithm for replication, and they can be these node connections. They can be so a node can connect to other node as client, but it also acts as a server and accepts connections from other nodes, and it makes a bit even more complicated. But yeah. So, and I was relying actually on the bare bones TCP socket connections of the on the bare bone Unix sockets. That is why I can run the software, for example, on Windows, because it just doesn't work the way. But implementing basic RPC with C++ 20 feature. Yeah, C++ features, parameter stack, printf. Yeah, right. It's actually straight from Java. If you want, if you want to really learn the programming itself, all the data structures, I would actually suggest you start with Java. At least, yeah, that's what we did at the university. So, fortunately, I have by a couple of years of some enterprise-like development behind me, but yeah, we officially started with Java, and it was it was funny. It was there were many things I learned at the university. So yeah, but there are a lot of online courses which is more than enough actually to go. So yeah, if you printf, Oracle PA list variable. Yeah, variable list. Extracting from here. Right. Nothing new. Primary lock. Package user specifies the template arguments. Yeah, that's not what I want. I know what. I haven't actually properly used the whole templates, but I know what they're for. The sequence. Yeah, implementing GDR RPC. That's what I'm interested in. Serialize arbitrary number of arguments into a byte stream. Temporary container for STL containers. Oh, okay, right. So unit ATT for some reason, but serialize function name. Arguments. Invoke tuple. Yeah, there's some serious there's some serious the thing I actually did like about the C++ is how errors are built, because and I'm not talking about like some semicolon or something, but for example compiling a C++ invoking a constructor with some wrong parameters, it won't trigger an error, a direct error, but it will the errors are just it's just horror, right? So they're unreadable and whatever, especially if there is yeah, because well, the Tetroflow, the system itself relies on actually on a shared pointer. So nearly everything here, as you can see, is a shared pointer. The main rule I use here, this is a Google main rule, and at many companies, you're just not allowed to use the direct pointers, if not really necessary. This case is just a small exception, right? So you won't find anywhere except some I think that's the only place where I use the direct pointer, a real C pointer. Everywhere else you see just shared pointers. There's just only shared pointers. In some cases it first of all keeps the application secure, so it guarantees that the memory, the object always really exists in the memory, and it also guarantees I don't have to worry about unloading it, because if the shared pointer is built the way in C++, so if it's not referenced anymore, so there's a reference counter, how much code is what parts of code are using it, and if the reference count is dropping to 0, so basically it's not used anymore anywhere, it automatically invokes a destructor and it frees the memory it points to. So it freezes the memory and destroys itself. So it's acted as a kind of natural garbage collector, which yeah, it saves some time programming, and it makes the things much easier. So grpc function, unique function name, serialize name arguments that are used to execute the function on the remote side, to remote node on the remote side, deserialize the data and execute the requested function with no shit, Sherlock. Sorry guys, but yeah, no shit, I could do it myself, and it would be much easier than that. Holy shit, yeah, there's some serious C here. Apple arguments. Yeah, I mean the code the codes maybe much looks much more professional, and it was written, I bet it was written by a fucking C professional, because with all this hacker std used lambdas. I fucking sorry, I hate lambdas. I mean, in Java they're sometimes helpful, only in case of streams actually, but I don't like any purely functional programming languages. I don't really like Haskell or Elixir. Yeah. Serialize. Make index sequence tuple size be removed. Yeah, this is kind of more readable, but yeah, on the other hand, I kind of have to learn. But still, you have to manage to open the connection, and I guess the best option would be to keep the connection open. To invoke gRPC. Broken suggest me how to read someone's code. I feel difficult time when I have through GitHub code. Can you steps learning path a real industry role? Yeah. So first of all, you have to know the syntax. Without knowing a C-like syntax, I'm afraid you can't begin anything, right? Well, yeah, it depends actually also on the what kind of code you're reading, because I hope my code. Okay, right. Did some Unix POSIX code. It's a bit complicated, but yeah. So learn uh, some programming patterns, right? For example, all the OP, some yeah, encapsulations, some. Wait, I'll try to show you some list. So yeah, first learn syntax, and you know what problem I had learning to develop? Unfortunately, I can't show you my Java code, my well, the real enterprise Java code, because it was written for some enterprise purposes, and I obviously cannot show it because it's considered private. But I also had trouble reading the code and understanding it until and I tried to do some projects myself, and at the end I took a look at my code and I thought, what the fuck? It really looks similar to that production code I couldn't understand. And then I took a look at the production code, the quote professional code, right? I took a look at the professional code, and then I was like, oh, now I can read. Now it kind of starts making sense. So yeah, I don't think you can you need to actually learn to read it. I would suggest you learning the syntaxes. Pretty good, right? It's one of the most important things, I think. Yeah, and learn to code. And if you can write the programming, code the programming language on a more or less decent level, you'll understand that it will slowly come. Any books? Books? No, I haven't touched any book. I must admit. If you want to learn about learn by doing projects, yes, exactly. That's the only thing you can really learn, because I started programming when I was 8. I started to help some companies out. It's a long story. When I was 13, and I was actually my first. And I graduated the high school, this special high school, as a language specialist. So I officially never ever learned how to code until before I went to the university. I officially never ever learned how to code, and I managed to do some, let's say, some smaller projects. But yeah. So yeah, you learn to code. If you want to learn algorithms and data structures, you better take Donald Knuth. Just wrote it to the chat. So he's the king of the algorithms and data structures. So you better read his books. But it's only data structures. You have to know how to code, and just learning by doing, right? That's the only way. I actually one time I tried some Udemy course, but it didn't actually bring me anywhere. You see some videos. Well, when I began really coding, the first thing I did is just typing the code. I saw the video, I was looking at the code and was just typing the same code, right? So yeah, I was just typing the same code, and it kind of drills your brain to use to typing the code to the syntax, etc. And you kind of start to analyze the code yourself, and you're writing it yourself. Or if you're working on a project, you have a trouble here, you have a bug there, and you have to figure it out yourself. And one big one big mistake many people do nowadays is using ChatGPT and or other copilots or any other AIs. No AI. When I start, when I sometimes sometimes start thinking, I will auto complete the code using the AI, but then I'll just press enter, complete, and it does, well, it basically does the stuff I wanted to do, right? And it auto completes the everything I wanted to write myself. But then I think, what does it again do? Then I say stop. I remove the whole code and I rewrite it myself manually, so I don't basically lose the ability to manually think about the code, to manually write the code, etc. It's also helpful. Yeah. Yeah. We have to kind of think of a solution how to, well, replicate all this stuff. So yeah, what I was thinking is, yeah, so that's gRPC, but it doesn't make a lot of sense here, because I still don't know how to implement the nodes, how to implement the node topology, etc. itself. And obviously Scala DB documentation doesn't explain much because it's proprietary software, but it's pretty good. Oh, sorry, there's the advertisement again at the background. Yeah. Oh God, I hate it. Unfortunately, I'm streaming off my second YouTube account, and I'll start working on a project from today. Yeah, go ahead. I mean, if you want to read some simple C++, you can again just go to the Tetroflow. It's it's exactly this project right here, and try to read some code here. And try to read some code. If you want, just yeah, there's some more complex stuff, but yeah, go ahead and do something. So yeah, it's complicated, but I think we can figure something. Proportion v nodes assigned to each node and cluster is configurable. Yeah. Page helpful? No, not really. Token range. So yeah, they're kind of distributing they're tokenizing the primary keys, as I understand it, and this basically split them through the nodes, and then each node is actually a subnode where the data stored, but I don't actually get the other algorithm. So wait. The joining above, each number represents a token range, right? With a replication factor of 2, we'll see each node holds one range from the previous node and one range from the next. Oh, now I'm kind of starting to get it. Our skill is exclusively rules of V-node-oriented architecture. Virtual node represents continuous range of tokens owned by a single Scala DB node. The physical node may be assigned. Well, it starts making sense. So, yeah, the first node stores the data of the yeah, but what happens if if one node just drops? That would be a mess, right? Yeah, it won't be good, but yeah. With replication, yeah. So, okay, right? It's not exactly what I wanted to do, because I want actually to do the whole replication, because what I want to do is basically maybe you have one server, one Tetroflow server running the main instance, and you have a kind of maybe Kubernetes host with, or a Docker host or whatever, with or with all the nodes which can be dropped at any time or stored at any time and become in sync. With the yeah, they will become in sync. Yeah, so they will become in sync, so at any time I could, for example, drop one node here or start one node there, we will instantly become in sync. But if this node here drops out, that there's still another node, or they can directly communicate with each other. So I think the best option here would be, let's say, building a, first of all, maybe building a kind of topology tree. Yeah. So what I would suggest is actually building a topology tree, right? It's a kind of topology tree. Let's call it a kind of topology. Yeah. So what I would say, for example, there's a node. Why am I so slow now? Because I'm thinking, I have to think about it and think it through, like, just right now. Right, so there's this node. This node gets a connection from another node. So they're both in sync. But this node itself, then this node itself is connected to another node. So connecting to this node here, this node has to tell this node here, like, about this node. Yeah. And now if this node, for example, has a connection to another node, then this node would tell this node about this one. So what happens next? This node establishes an exact connection to this one and tells this node about this one, and it establishes the connection to this node and vice versa. So now we have it. So yeah, this node's this node's running. This node is connecting to this node. This node has a connection from this node, and there are telling everyone about what nodes I currently have. What nodes is connected to. Oh, sorry, I got. Oops. Yeah, I got a message. Yeah. Oh yeah. Today is Halloween, right? Happy Halloween. Yeah, I'll have to go in an hour, I think. Yeah. Just got a Telegram message. I have to go, unfortunately, in an hour, but yeah. So what we could do is oh yeah, actually we have to remove all the messages. Yeah, there don't actually exist message types. So let's create a new folder. Cluster. Let's call it cluster. Let's call it cluster. Let's call it a cluster. And let's create a node.hpp. Let's create a header file. Yeah, now we're coding. Now we're coding something, right? Yeah. So what does a node have? There should be. Oh, I'll take a look. There should be a data structure to building up some like topologies like that. So this node's connected to that node, and that's connected to that node, and it should be everything in sync. Yeah, well, that will be hard, but I will learn something, and that's exactly the point. So I'll learn something, right? Class node, class cluster node. Okay, yeah, but the thing is, not all cluster nodes will be connected to a it's not term less log index node. Oh wait. So it's actually suggesting me to see it's actually suggesting me to use the last log term get cluster get node status, get node role, get node vote, right? So it's actually suggesting me to implement this voting algorithm, this raft algorithm. So there's a well, obviously as I mentioned, there's the main node and there are all the nodes around it. Which are voting for this node, and it becomes the main node. But it can, well, I still don't fully understand how they solve the problem in Scala, but I'll do it a bit otherwise. So cluster node, int 64e. It's not an ID, it will be, what will it be? Last heartbeat. A loader. Oh yeah. I have to include some stuff. Yeah, so the node, what does it have? It has a heartbeat. It obviously should have a socket connection to it, or at least some kind of tunnel, right? And it has to have some underlying nodes, right? So we're basically building up. Oh yeah, wait, there's what if a node is actually, what if a node, so I was thinking like if this node here has connection to here, to this node here directly, and to this node here again indirectly, so that would be repeating itself. So That's not good. Maybe I've heard we have a networks, I don't know what's called, like it's seminar. It's yeah, it's a subject at the university, and it's called networks. And what we're doing there is yeah, they told us something about optimal path network path finding, where you could, for example, split connection between two nodes, thus making sure that there are no circular packages running around. I actually don't want to implement it because they said that that it's a master subject, and that it's one of the most complicated things. I mean, it's possible, but yeah. So in the node we have a heartbeat. We have and yeah, known, alive, or dead. Yeah, that's mandatory. So obviously we have cluster node state. We know that it's state in a heartbeat, and yeah, there should be kind of tunnel to this node. There should be kind of we have to build up a tunnel to this node, and then the whole socket stuff will be, yeah, maybe so. Yeah, each node, whether it's connected or not, doesn't matter. Doesn't matter in this case. So that we can, for example, there's this node knows about that node, but there is a such connection like over here, and there is the connection which goes around this node, like kind of pipes, right? So maybe do something like this pipes. Yeah, I mean, planning is harder than implementing, I should say. So in this pipe, it will receive messages and it will send messages. And what kind of message? I mean, I guess replicate messages. Yeah, again, I don't want to split information, because yeah, because of that architecture I want to keep, and that the other node is can pretty easily, pretty fast turn on and turn off, go up and down again, and yeah. So maybe that. Yeah. Yeah. So I was thinking about, yeah. So I don't want to actually split the data, which makes the whole stuff much simpler. I don't want to split the data. I just want to yeah, I just want to make it simpler. I just want to keep it consistent and even redundant. But yeah. So maybe create another less heartbeat app. No, I don't want to work with the acknowledgements, and it gets much more complicated. But cluster node ID or something. Yeah. So yeah, we need to also implement the messages and the message types. So the message types, yeah, there's a heartbeat, join, leave, heartbeat, replicate. And now I have to design what it looks like. So yeah, replicate basically replicates data. But what I was thinking is what it did in the previous version, in this so to say preset, like looking around, trying around version, what it was doing is to so what this thing was doing is it was basically taking the command from the basically taking the command from the what was it again? Yeah, from the executable. It was like from the queue when the there is a main queue which where transactions wait to be executed, and it took the transaction and packed it into a package and just sent the commands of this transaction, which in most cases were just one command transactions, right? They just sent the transaction to the over the network as a JSON, and it was just unpacked to the commands, converted to the transactions again, and it was sent to the transaction queue of the other nodes. But what could be the problem? For example, the increment data. The increment command, for example, when the increment arrived, because of the latency or whatever, it could easily happen that the data was already incremented. So what to do? What it did, it just incremented the data one more time, which could create inconsistencies, which goes actually against the ACID principles, even though I don't actually care about ACID in this case, because it's just an in-memory only, but yeah. I don't want to keep it inconsistent, so it's great. Also, what I want to do is implement a kind of what I want to do is implement a kind of message broker, so you can from the client perspective you could subscribe to a message to a channel, and you can listen for the messages, and for example also all deletes, all writes, all updates, etc. They're actually all already messages, also messages. Yeah, but now I'm thinking about an important thing, and this is how to send the data, because so obviously I don't have to send the command, but the resulted data, right? So but come on, I mean, write ahead log. I mean, Postgres uses the write ahead logs, and other big databases also use write ahead logs. So maybe it's not that bad to send the command itself, but again, it could cause some inconsistency. Just sending a new state, right? Yeah, the problem here, the main problem here is that the well, I'm thinking about is the some nested data types. For example, in this case, for example, Redis can't do that, right? Redis can't, but the Tetroflow can. A list, in this case, is, for example, a list is made from it's a data type, and it's made actually out of other data types, smaller data types, but they are all sub data types, are also considered separate data types, and yeah, can be handled as Tetroflow data types. So for example, when getting a list, you can send for example save a list with lists, with sets, with some random data, where somewhere there is another list and another sets, and it's kind of nested, and the what the parser does is it's going through them, and recursively obviously, and just parsing them around, and yeah, building up the yeah. the more or less data tree, but you can't really make much to it, unfortunately, because the data. I tried to implement my own data manipulation language, but it was way too hard. So I wanted to keep it as simple as possible with JSON, and unfortunately, the JSON doesn't support it. So yeah, that's the only solution, unfortunately. So yeah, let's create a message. HTTP. Let's create a header at least. Oops. Yeah, you insist. Message. Receiver message ID center. Yeah, maybe center ID, but I'm not sure. No, I don't want to send a string. Yeah, I don't want to send a string. What I would want to center's message ID center ID is also a U64T. No, I'm stamped. Yeah. So now maybe std we should include vector. Let's use the standard vector, and one of the main reasons why I especially choose the yeah, but I wanted to actually use the byte std bytes data, a vector of bytes. What's actually the difference? I actually don't know the difference between them, but std byte versus unsigned integers. A canonical byte, the canonical byte type, character legacy byte type, small arithmetic type. Signed char, no special properties. Yeah, I would actually. Yeah, I just name a character. Signed char and signed char. No, I become a C++, which by send these bytes. Now that the byte is very special because there are many extensions that allow you to use the type in otherwise undefined ways. For example, strict aliasing is a relaxed way, meaning you can examine any object as an array of std bytes. Whoa, whoa. Wait a second, really? So wait a second. So I can just wait a second. I can just cast any object to a vector of std bytes. Really? I can cast just like any object into and cast it back? Wait a second, there's no way. There is no way, because I was thinking like, how would I do this serialization? Because I hate like serializing around it, especially in C++. Serializing and deserializing into fucking bytes. I'm so sorry, right? Holy shit, I can do it like I can natively cast it or something. Let's ask ChatGPT, right? I'll do it off cam, obviously, because you don't see all my other queries, which can be related to my job or to my project. Project's better to say, but I have a class. Sure. deserialized. Is it possible to deserialize it back to object? So yes, serializing object vector is possible and deserializing. Okay. Reinterpreter cast technique, assuming the object has a certain complex pointers or dynamic data, what would break? Simple copy. Fuck, cause it has. Cause it has. It has. Like. Well, it just reinterpreter casting it around. Yeah, in STD string. Why isn't there actually a mechanism to manually serialize not manually, I mean automatically serialize a string? You obviously you have to first tell how long the string is, what size the string has, because I mean I had similar problems with all this string serialization and deserialization, because it was a long time ago and I tried to send it was really it's really a couple of years ago. I was trying to send well, I coded using Qt C++ for Android, which made it even harder to debug. Running C++ on an Android emulator, and you gotta debug the whole stuff, right? So not the not maybe the best way to yeah. But again, what it also did is yeah. So I tried to send just the string, normal I mean normal Q string, and I was wondering what the hell's what the hell's wrong. But then I was told, yeah, are you needed? A Q string is dynamic, so it can be directly casted and sent, because under the hood there's still the pointer, this pointer stuff with so basically I get the first character sent and then the pointer to an address which wasn't unallocated, so I instantly get the segmentation fault because the operating system says, what the hell, this address does not belong to you, because on the original host I had the data at this location, the next layer, but on the new host I just send the first letter and the pointer to the next one, which obviously doesn't work. Yeah, so it wasn't, I thought it was pretty complicated back then, but I learned something out of it. And using JSON with library, yeah, the ChatGPT suggests me like the Rapid JSON or and Lochman JSON. That's exactly the library I'm using. Pronto flat buffers, person close platform compatibility and network, and these libraries can automatically handle vectors, strings, and even shared pointers. Some extending your rapid customization for shared resources. Yeah, well, obviously, but so I have to determine. I'll stream like next 30 minutes and I'll have to go now then, but so I'll have to determine what will I have to determine. I'll have to determine the way to I have to determine a way to serialize the message. Yeah. it actually should compile pretty fine, but it won't because I didn't include the HPP file anywhere, so it obviously won't compile. I mean, it will, but not the way won't even include the file and the thing about it, because it's not used, it's not included. No way. So the message. Yeah. So, serialize. Deserialize and let's make it virtual. Make it a virtual. Yeah, let's make it virtual class. Virtual message type. Stay there. Yeah, I won't need it. Yeah, because it's straight from Java, because in Java you have to well, define the class as abstract. If you use some abstract methods in there, a class can only then have abstract methods if it's declared as an abstract one. But yeah. Message ID, sender ID, timestamp. Message ID, sender ID, timestamp. So yeah, it's deserialized and deserialized. Yeah, it should be fine. So, and the message types, and the message type is join cluster message. With message, yeah. So yes. Oh, we have to include something. Yeah. Message types. It's a message join. So yeah, serialize. Yeah. So now I have to find a way. Yeah, now I think I have to think about how to the first thing, when the message then the when it joins the cluster, what does it do? Well, it obviously first of all notifies the cluster about its ID, I guess. I'm joining a cluster with the ID, and it just, well, yeah, we could make it easier and keep the gossip protocol. Oops. And keep the gossip protocol. Keep the gossip protocol, and it will just pass the yeah, it will just basically broadcast to all the connections that it has opened that there is yeah, that it's able to that it's there. Maybe something like that. Well, with it has to include its unique ID. We somehow have to guarantee that the ID is unique. That's also a problem. There is the change, the chance is pretty small, but there still is a chance that the ID is will be the same as with uh, with another, you know, data, and it will just send it to all the or some of the nodes it's connected to the message, and the nodes will mark it is well, they will obviously create the node. They will search for the node, and if necessary, well, if necessary, at the node. But what does the node have to have? Well, the and how to reach it from the so the cluster message has so maybe we could make something like a ping package. You know what it is, right? So not a ping but tracer. So or earlier at least. So it has some it was earlier, it was time to leave, but now it's called hops. And every time the package the package has a number of hops, and for every hop it's for every router which works with this package, one hop is decremented. One hop is decremented, and the package and there is a response, and then there is the response what kind of router just decremented the hop, right? So yeah, maybe we could do something like that. So for every node, when the node's joining, on the node joining, it has kind of an array with all the intermediate nodes, and when the node is sending the join message further, yeah, when the node is sending the join message further, it adds itself an ID of itself to the it adds an ID to itself as a yeah, as if it were. So it says basically I'm connected to this node, and yeah, I just give it further. Yeah, and it gives it adds itself and forwards it further. So the other nodes, basically, when they accept the message, they know, huh, this node is connected to that node, to exactly that node, and then instantly know the shortest path. I would actually like to also visualize that. It would be much easier if visualized. Yeah. So at the end, well, let me think. Right, so at the end, you have basically a tree where you exactly know how to reach one or another node. But what if the node which connects it to the other node via the shortest path just dies? What's then? What happens then? Yeah, if so, we have to implement a mechanism where if a node which is connected through one or another node through a node to another node, and if so it kind of detects that if an intermediate node dies, that it has to send a rejoin the cluster. So it was thrown basically out of the cluster and it has to rejoin and resync. So that's what we have to implement. Yeah, that's what we have to implement. Well, I think we'll continue the next time. So everyone, thanks for watching, and thanks for subscribing if you subscribed. If you didn't, please do it, and please take a look at the Tetroflow. So the advanced clustering, yeah. So look at the Tetroflow, and we'll see you later. I'll see you later.